there for preparing the organic compounds, there is a special force is being required, a vital force, which we called him vital force. A special important force is being required, or mysterious force is being required to prepare organic compound. To prepare organic compound, and we will simply say that here, that these organic compounds cannot be artificially prepared. Okay, these organic compound cannot be artificially prepared. So we have that a vital force, a mysterious force is being required to prepare organic compound, which is impossible to create artificially. So it is important that artificially we cannot means create the organic compound. That what earlier assumptions were there. Okay, but accidentally an organic compound was prepared in the lab, and that was urea. What was that compound? NH3 C double bond O NH3. Sorry, NH2 C double bond O NH2. Okay, that was urea. The urea was prepared artificially. First organic compound. First organic compound that is only found, first of all, this was initially it was only found in the natural beings. Okay, but it was artificially prepared from inorganic substance. And how it is prepared? Scientist named Friedrich Huller. What was the name? Friedrich Huller. Okay, he prepared it artificially. How it prepared? He was heating ammonium cyanate, NH4CNO. Okay, and when he was heating this one, then he heated and he got it NH2 C double bond O C. Okay, this was NH2 C double bond O NH2. So this is 2 nitrogen here, 2 nitrogen here, 4 hydrogen, 4 hydrogen, 2 and 2, 4, 1 carbon, 1 carbon, 1 oxygen, 1 oxygen. So these are the same molecular formula, but different structural formula is there. This is the different structure. So this ammonium cyanate is actually an inorganic compound. This is an inorganic. Inorganic means which is not prepared in the lab, or which is synthetically can be, which is prepared in the lab, or we can say that which is synthetically prepared. Okay, you can prepare it synthetically, or you can prepare it in the lab. Okay, and organic means that is present in the natural substances. Okay, this is the organic compound. Organic compound. So first, the previous definition that was given, that organic compounds can all that are those compounds that are found in the natural substances like plants and animals. But the definition has been changed now. Why? Because we can artificially create the organic compounds too. Okay. So if I talk about this one, that how can we prepare the organic compound? So there can be so many organic compound that we can prepare artificially from the inorganic one. What is inorganic? That is not found in the natural substances. Okay, that is found in the earth crust or some other substances, like carbon dioxide is inorganic, water is inorganic. Okay, that is not found. Water is found in our body. It means that it is not synthetically present. We drink water, it is not synthesized in our body. Okay, but like glucose is organic because glucose is prepared inside the living plants. It is prepared in the plants. Okay, urea is generally present in the animal waste. Okay, and it is actually prepared in the body. So it is not artificially prepared inside the human body. We don't drink urea. It is generally synthesized in our body. So, but urea can be artificially prepared in the lab also. Now, so the definition that was that organic compound are those compound that is found in the organics natural substances like plants and animal. It has been changed. So what is the new definition for the organic compounds? What is the new definition? So new definition for the organic compounds is that organic compounds are the compounds of carbon and hydrogen. Are the compounds of carbon and hydrogen. We call them hydrocarbons. Okay, and their derivatives. Derivatives means that has been derived. For example, if I'm just having this CH4, it is going to have this structure. Okay, if one of the hydrogen is being removed, and in place of this, a chlorine atoms come. Like we are just replacing this hydrogen, and after removing this hydrogen, a chlorine atoms come in place of this. So this is the derivative of hydrocarbon. Means it has been derived from this methane. So if we have CH3Cl, CH3Cl, then it is the derivative of methane, that is CH4. So what is the definition of organic compound? It is the compounds of carbon and hydrogens and their derivatives, and it may also contain nitrogen, phosphorus, sulfur, and few elements like sodium, sorry, few metals like sodium, etc. Okay, so please note it down, this one definition for the organic compounds in your copy. Everybody understood or still having some doubt? Understood? Tell me.
Yes, sir.
Only one student is going to reply.
Yes, sir.
Note it down fast. Hmm. Done. Note it fast. Nobody is going to take the screenshot, and please prepare separate copy for chemistry, physics, and bio. Don't intermix your notes.
Sir,
Yes.
sir, should we write the CH4 also?
Yes, you have to write this one also. How can you explain the derivatives? They may also contain nitrogen, phosphorus, sulfur, and few metals like sodium. Done.
Answer.
Okay. So let's start. Now, note it down. Note this one, that the first organic compound was prepared by Frederick Kohler, and noted down that see this equation, that he was preparing ammonium cyanide from ammonium chloride, okay, and potassium cyanide, and then he further continuously heat this one, then he got this one, okay, ammonium urea, which is an organic compound, and ammonium cyanide is inorganic. He proved vital force theory wrong by preparing organic compound urea by or inorganic compound ammonium cyanide. Please note it down. Done. Done? Should I move forward? Tell me, should I move forward?
No, sir.
Just a minute, sir.
Just
Done, sir.
hey, is there anyone still writing? So who
No,
proved?
sir.
Okay.
No, sir,
So may I know that who proved the vital force theory wrong? Who proved vital force theory wrong? Burgess gave the vital force theory, but it was proved wrong by Friedrich Wöhler. Okay. And how he proved wrong? By preparing ammonia from ammonium cyanide, which is an organic compound, and ammonium cyanide is a inorganic compound. Okay. Let's start. Now, this is very, very important. Okay. Now we shall be moving towards that IUPAC extend means if we means we can say that IUPAC means writing the name of a chemical compound or a hydrocarbon compound is not in the STEM syllabus. Okay, but basics of IUPAC we should know while writing the names, while we are just studying this chapter. For example, if a name is being written here that sodium ethanoate react with this one, so how will you understood that what is sodium ethanoate? Why the name of ethanol is ethanol, not methanol? Why we have ethanol is C2H5OH, and why methanol is methanol? Sorry, this is ethanol C2H5OH, and methanol is C3OH, CH3OH. This is methanol. So there can be some confusions, and for better understanding and for taking the interest of this chapter, we should learn the language of this chapter first. And the language is the IUPAC, or we can say that International Union for Pure and Applied Chemistry, that how can we write the name of a carbon compounds. Okay. So we are not going to study this one in very much great detail. We're not going to deal with very only those topic, only those compounds or the names of those things that we're going to study in this chapter. We're going to deal with that one. We are going to learn the names, that how we write the names of those compounds, because the language is very important for of this chapter, and language is nomenclature of the IUPAC compound. Okay. So if the nomenclature of the IUPAC compound, if we are not able to study properly, we are not able to understand properly, then we will not be able to understand this chapter thoroughly. Okay, so this is must that every student should know how to write the chemical formula of the compound of the hydrocarbon, and we will just learn the basic of that one. Okay, in today's class. So first of all, we need to learn that what are functional group. What are functional group? Okay, so if I talk about the functional group, we can say that it can be an atom or a group of atom. What is it? Can be an atom like chlorine, chloride ion, okay, like hydrogen, like OH, okay, OH, okay, an atom or a group of atom or a carbon chain. This is a chain of carbon. The whole carbon is CH, this is CH4, okay, but when we remove a hydrogen from it, then it become a chain apart. Okay, so like we have CH3 COOH. This is ethanoic acid. So what is this CH3COH? What is it? What is this COOH? This is a functional group. This is a functional group. So this is COOH is a functional group. Okay, so we can say that what is a functional group? An atom or a group of atom attached to an hydrocarbon chain. For example, if I'm having this CH3, CH2, CH2, CH3, okay, this is a hydrocarbon chain. Okay, And like I'm just representing here that every carbon can make maximum 4 bonds, and here this carbon is attached with 3 hydrogens and 1 with this carbon. You can have this structure same like this: 1, 2, 3, and 4, and 3 hydrogens here like this, 2 hydrogens here because it has already made 2 bonds. Has already made 2 bonds, and this is 3 hydrogen at the terminations. Okay, so if we remove one of the hydrogens, and add an atom or a group of atom to it, like we have added OH to it, okay, then this whole hydrocarbon chain will start behaving the property of this functional group, of this group of atoms. And this OH is a functional group of alcohol. Don't understood that it is a base. In hydrocarbons, if OH group is attached, it means that it is alcohol group. Okay, alcohol. So it is alcohol. And instead of alcohol group, OH group, if I attached COOH, then this whole hydrocarbon chain will start showing the property of acids. This is the functional group of carboxylic acid. Carboxylic acid. Okay. So this group of atom or an atom, when they are attached to an hydrocarbon chain, then it is start, or we will say that it start determining the property of hydrocarbon chain or the whole hydrocarbon. So we call them functional group. So what is the definition for functional group? An atom or a group of atom attached to an hydrocarbon chain that determine the physical and chemical property of the hydrocarbon is called functional group. Okay. If instead of COH, if I wrote here, or if it is having OH group, then it will start behaving property of alcohol. If I write here CHO, then it will start showing the property of aldehyde. Okay, are you getting my point? Getting or not getting? So functional group is in syllabus. So we're going to study with this one also. Okay. So if I talk about that, what is functional group? To note down: an atom or a group of atom attached to an hydrocarbon chain that determine the physical and chemical properties of hydrocarbon chain is called functional group. Okay, like I'm just saying here, if it is attached with OH group, then it will be showing the property of alcohol. If it is attached with the COH group, then it will start showing the property of carboxylic acid. Okay, so there can be different functional groups that we're going to study. To note it down, the definition. Language of this chapter is very important. Okay. Done. Note the definition of functional group only. An atom or a group of atom attached to an hydrocarbon chain that determine the physical and chemical properties of functional group of the hydrocarbon chain is called functional group. Noted? Done? Nobody is answering.
Yes, sir. Answer.
So why
Yes,
are you
sir.
not replying? Everyone
Done,
is
sir.
kept. Is there anyone who's still writing? Should I move?
The 1
Is there
minute.
Okay, noted fast. Jaslyn, why you joined late? Jaslyn, are you there? Jaslyn. Jaslyn is in the class.
Yes.
But she's not responding. Okay. So if I talk about this one, that done. Okay. So let's move further. Now, if I'm just writing the two names here, okay, like I'm writing a name here. I'm writing a name, Muhammad bin, okay, not bin, okay, Muhammad Arslan Khan, Arslan Khan. Okay, so this is the main name. This is the prefix, and this is the suffix or surname. Okay. Like we have a middle name, a first name, and the third name. In the similar way, in the IUPAC compound, we also have some name which is written first, okay, before the main name, okay, before the main name or the middle name, okay. And there's some name that is always used as a surname, okay. For example, if I'm writing two names here, that is 2-chloro, 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 3-methyl, 3-methyl, pentanol. Okay, so for example, it is being written here. So here, this is chloro and methyl. Methyl is a carbon chain, that is CH3. We'll learn this one. Chloro is Cl group. The name of chloro and this methyl is written as first name before the name of the main. Pent here is representing 5 carbon chain. It is representing 5 carbon chain. We will learn this one how to write. And ane is representing An. Ane is representing single bond between all carbon atoms. And ol is representing here alcohol functional group. Alcohol. Okay, so we're going to write here that here are some functional group. Their name is written as suffix. It is written as suffix. And there are some functional group. Their name is written as prefix, like chloro, methyl, ethyl, bromide, bromo, okay, nitro. So their name is written as prefix. So we will have the table of functional group. Some of their name should be written as suffix. Some of their name should be written as prefix. Okay, so we're going to write here. For example, let me write. First is serial number here, functional group. This is RH. This is COOH. Okay, carboxylic acid, COH. The functional group is COH. Its structure is like this. Let me write it by my own. Okay, so if I'm writing here that the first one is the functional group is COOH. Okay, here R represent the alkyl group. And what is alkyl group? Let me explain you. Alkyl group. Alkyl group is a carbon chain. If it is carbon chain like CH3, CH2, CH2, so this is a carbon chain which it is representing. Okay, since the functional group in the functional group COH, there is already carbon present, means this is the functional group which has its own carbon, that you understood what I'm saying here. In COH, the functional group has its own carbon. So the shortest or the minimum formula that we can write with one carbon chain, with one carbon, means if I'm saying that a functional group is attached with some hydrocarbon chain, then it determines the property. Okay, like for example, if I'm writing alcohol, the simplest alcohol can be one carbon chain. This is one carbon chain. The 2 carbon chain is this one, is the 2 carbon chain. Okay, the 3 carbon chain is this one. Okay, this is the 3 carbon chain. This is the 3 carbon chain. Okay, so if I attached functional group alcohol with this one, OH is the alcohol functional group, so it will become 3 carbon alcohol. If I attach with this one, so it will become 2 carbon alcohol. It will become 3 carbon, one carbon alcohol. Okay, so these are all alcohols: 1 carbon alcohol, 2 carbon alcohol, 3 carbon alcohol. But since alcohol functional group do not have its own carbon, so we need to add at least one carbon chain, that is CH3, to make a proper alcohol. But since in this carboxylic acid, we don't have, sorry, we can say that it's the functional group has its own carbon. So we need not to make, or we need to, for making the simplest carboxylic acid, like for example, carboxylic acid's functional group can be represented like this, COOH, or we can write it like this, C double bond O and OH. This is the functional group of carboxylic acid. This is COOH. Okay, this is the structure. So for making simplest carboxylic acid, we need not to make a one carbon chain to it. We need not to write it. Okay, because it has its own carbon. So still, if we have only one hydrogen attached to it, only one hydrogen attached, because it has its own carbon, so that carbon will be counted as one carbon, and it is the simplest carboxylic acid. This is called methanoic acid. Methanoic acid. This is found in the end state. Okay, this is HCOH. So I'm writing here R. R indicate the carbon chain, and H represent the only if we are using H, then it can be here. If you can use H, you can use chain. If I'm using this one carbon chain instead of hydrogen, so here it is the carboxylic acid of 2 carbon, not the 1 carbon. You have added 1 carbon chain, but this carbon will also be counted. Understood? Understood,
Yes, sir.
everyone? Okay. For example, if I'm having, okay, so those functional group that is going to have its own carbon, like aldehyde also. Aldehyde is CHO. Aldehyde is CHO, and its structure is like this, COH. This is the functional group named as aldehyde. Okay, aldehyde. So since this functional group has its own carbon, so we need not to add us for making simplest aldehyde. Simplest aldehyde can be of 1 carbon, and this functional group has its own carbon, so you can replace here 1 hydrogen in order to complete the 4 valencies of this. If we have 1 carbon chain attached to this one, now it will become 2 carbon aldehydes. This is 1 carbon here, functional group, and another is chain. So you add only 1 carbon chain, but it will be counted as 2 because the functional group carbon is also counted. Okay. The simplest aldehyde is this one, and this is methanol. Methanol, and we will discuss how it is methanol, why the name of ethanol is ethanol. Okay. But in case of ketone, the third functional group, this is important. The ketone is CO, and its structure is C double bond O. But you need to keep in mind that rather it has its own functional group, but at least to make simplest ketone, we need to add 1 carbon chain to this side and 1 carbon chain to this side. Means simplest ketone can be formed by 3 carbon. It cannot be formed by single carbon. It is a condition for the ketone. Why? Because if we use C double bond O and we use H here and H here, then it will become aldehyde, CHO. That was, we have written here, CHO. So ketone is same, but to aldehyde, but it must have ketone group. Simplest ketone can be prepared by 3 carbon. We must have at least 1 carbon chain here, okay, and 1 carbon chain here. So this is ketone functional group. It needs 3. If we have two carbon ketones, is it possible? We have 1 carbon chain added here and 1 hydrogen here. No, it will again become aldehyde. So this is 2 carbon aldehyde, not 1 carbon ketone. 2 carbon ketone. Okay. So for making ketone, you can add unlimited carbon, but at least there must be 3 carbon. 1 carbon on the left, 1 carbon. Ketone group cannot be used at the termination carbon. Termination means the end carbon. End of the starting carbon or the end carbon. You cannot use ketone group. You will use ketone. You can use ketone previous previous to the terminations carbon. Okay. Okay. You can use ketone carbon here. You can use here. Okay. But you cannot use it on the termination. You cannot use here and here. Okay. So simplest ketone can be of how many carbon? Tell me. It can be of 3 carbon. You understood? Understood? Nobody's answering.
Yes, sir.
Okay. Now you need to keep in mind here that this is a functional group. I'm writing here H because its there is no there is no means terms and condition for the uh, carboxylic acid that it must have three. No, it can make carboxylic acid with simplest one carbon. So if you use one hydrogen atoms to this one, it can also make, but the main functional group is COH. Okay, and this is the structure, and its name is carboxylic acid. And here we don't, in 10th standard, we don't use carboxylic acid prefix. So we are not writing here prefix because it is not used. It is, if it is attached, then its suffix will be used. Means its name will be written at the end and not the whole carboxylic acid. Only the part oic acid we will use as a suffix. Only the oic acid. Okay. You understood? Similar for the aldehyde. Aldehyde is CHO. You can use H, you can use chain, but the functional group is CHO and the structure is this. And its name is aldehyde. And we use suffix for this one also. And there is al. Suffix for aldehyde is al. 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 Okay. Not the all for full aldehyde. No, it is only al. For ketone, I'm not writing here H because you cannot use H. You can use R, and R is carbon chain, representing carbon chain. Okay. So there is three carbon. You cannot use hydrogen here. Okay. So this is RCOR and this is ketone group. And for this one, we use on as a suffix. ONE, on. Don't say it one. Okay. It is on. The next one is alcohol. For alcohol, R is compulsory. Means there should be one carbon chain at least because it does not have its own carbon. So at least one carbon chain should be there for preparing the simplest alcohol. And its structure is also same, ROH. And its functional group name is alcohol and its suffix is used as OL. Now we have nitro, NO2. Structure is this, like this. And nitro, in nitro we use prefix as nitro. Whenever nitro is being written or attached to a carbon chain, we use its name as prefix. Means it will be written as before the main name. Okay. So this is prefix. Okay. Understood? Understood? Getting my point? Nitro, alcohol,
Yes, sir.
aldehyde. The next one is halogen. Halogen groups are like chloro, bromo, iodo, fluoro. So attached, if they are attached, their name is also written as prefix. So we will use here that this is these two nitro and halogens groups are written as prefix. If it is not till note down the question up to note down the functional group up to 6. Okay, note it down fast. Make the table and note it down fast. And write it properly. Okay, don't write it. Don't miss anything. Okay, write it properly. This chapter is very important. No one is going to take any leave for this chapter. Okay, this is very important chapter. Otherwise, you will not be able to understand this chapter, because this is the first chapter of the organic chemistry. You never have up to ninth standard, you have not studied anything about the organic chemistry. And in the 11th and 12th standard, you have a separate book for the organic chemistry. Okay, so this is the very, very important and basic chapter for the 11th and 12th standard for your concept, and also very, very important for the 10th standard also. And so that's why I'm saying that do not miss this chapter, because it is the basics of chemistry, organic chemistry, and the first chapter that you have not studied till yet. Okay, so hydrocarbon, related to hydrocarbons. So don't miss any class for this chapter. This is very important. Okay, note it down and then let me know if you have done. Okay.
Can you scroll down?
Yes, I can scroll down here. Okay, if we have two, means for example, if somewhere is one carbon chain attached like this, for example, if this is a main carbon chain, and if we have one carbon chain attached like this, if it is, this is a main carbon chain, and if it is two carbon chain attached like this, so this two carbon chain formula will be C2H5. Why C2H5? You know that this is the two carbons, and if you have one hydrogen here, one hydrogen will be here, and this will have three hydrogens here. So this is actually C2H5. C2H5. Okay, so this is ethyl group, ethyl. And if we have one carbon attached like this, CH3. Okay, one carbon attached like this. So this, their name should be written before the name, before the main name. Okay, we will learn that how will we write, but this is called alkyl group. This is also alkyl group. This is also alkyl, means chain of carbon is called alkyl, and we represent it with R, but they have different names. Alkyls are can be different type. If it is one carbon alkyl, then it is methyl. If it is two carbon alkyl, then it is ethyl. Okay, so their names are written before. Okay, for example, if we have CH3, so this is alkyl group, and their name is written prefix. Okay, and how it is written, we will learn. If it is one carbon alkyl, his name is methyl. If it is two carbon alkyl, it is ethyl. If it is three carbon alkyl, it is propyl. So we'll discuss. Have you noted this name here? This whole chart. Tell me.
Yes, sir. Just a minute, sir.
Okay, note it down. Write properly. Chloro for chlorine, bromo for bromine, iodo for iodine, fluoro for fluorine.
Done, sir.
Okay.
Done, sir.
Done.
Yes, sir. Yes, sir.
Okay. So how can we write the name of a compound? Okay, let me tell you. There are some rules. Okay, and how to write their names, let me tell you. For example, if we have a 4 carbon main chain, okay, and if it is attached with some functional group like alcohol, and if it has double bond somewhere, okay, and then we have a carbon chain here like this is the carbon chain, and we can have a branch also here, 1 2 3 4, it has made 4 bonds, so we can have a branch, like we can have here chloro group, Cl group. So their name can be written. How can we write the names of this one? There are some rules. There are some rules. And what are that rules? Okay, that are very important. Okay, the first is what is the means, how can we write? So first, a compound has we can say that there must be prefix. There must be prefix first, then root, then saturation, indicator, 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 and then we have suffix. Okay, suffix. then we have suffix. Means these are the four part of a IUPAC name. Prefix can be or can't be. Means we can have a prefix. It can be one or more than one. Like for example, it is a carbon chain. It is chloro here, it is bromo here, and it is one carbon chain. So one carbon chain and these names should be written as prefix. Okay. So we'll use chloro, bromo, and methyl. So their name should be written before the main carbon chain. The prefix can be one. If it is how it can be one, like this, only one prefix. It can be more than one, like one here. Okay. The prefix can be one, more than one. Okay. And can't be, not necessary. If it is like this, there is no prefix, only a carbon chain. So it is not compulsory that prefix must be there. No, it is not compulsory. It can be, or if it is present, it can be one or more than one. Understood? Understood?
Yes, sir.
The next one is root. Root is the number of carbon chain. Number of carbon in the chain. In the chain, it is represented. For example, if we have 4 carbon, then for 4 carbon in the main chain, we will use bute. What we will use? Word bute. For 4 carbon, we use bute. For 2 carbons, we use eth. For 3 carbons, we use prop. Okay, for 3 carbon, we use prop. So bute, eth. For single carbon, we use meth. For 5 carbons, we use spent. Okay, we use spent. So main, these are the root words. Spent, bute, prop, meth. Okay, so this is bute. Is the number of carbon. Saturation indicator indicates that what are saturated and unsaturated compounds. So we're going to learn this one. Okay, saturation means if it is carbon-carbon single bond every time, carbon-carbon single bond, then for this one we use A and E. If it is carbon-carbon double bond somewhere, then we use E and E. If it is carbon-carbon triple bond somewhere, we use Y and E. For example, if we have 2 carbon only, okay, no prefix, no suffix, no anything, simple. So this is 2 carbon. So for 2 carbon we use eth as a main chain, 2 carbon, and there is carbon-carbon single bond, we use ethane. So name is ethane. If we use 2 carbon but there is double bond between 2 carbons, so their name should be eth and then ene, E and E. Okay, ethene. And if we have 3 carbon like this, if we have 3 carbons like this, one hydrogen is there. So this is eth 2 carbon and YNE. We use YNE. So this is ethane or ethane. It is ethene and this is ethyne. Understood? So depending on the name, if it is bond more than two double bond, single bond, a triple bond, the name is IUPAC name is written accordingly. You understood, dear students?
Yes, sir.
So please keep in mind that what I have teach you today, and I'm not going to teach you the rules and how to write the IUPAC name today in today's class because time is not there. Only we have 10 to 15 minutes. So we're going to discuss some other part of this chapter. Further parts, the IUPAC name, that how we are going to write. We have studied the functional group. You have a memory of functional group. What is prefix, suffix? We will discuss this one from the starting in the next class. Okay. So let's start studying. Let's start studying today's, that is what is saturated and unsaturated hydrocarbons. Okay, what is saturated and unsaturated hydrocarbon? Unsaturated hydrocarbon. So if I talk about the saturated and unsaturated hydrocarbons, so saturated hydrocarbons are those carbons. For example, what do you mean by word saturated? For example, if you have just if you are moving on a train, okay, if you are moving on a train and this is a train seat. Okay, I'm talking about the Indian train. I've already I'm only seated in the Indian train. I have never seated in the westerns or some other country. I'm not gone there, so I don't think you are just, you all have enjoyed that one. So I'm just talking about the Indian trains. So for example, this is my reserve seats and I'm sitting here. Okay. I'm sitting here. Okay. Like this. Oh, what a diagram of me and my unit. Okay. But this seat is also reserved, but the passenger has not come here. Okay. Okay. So what you will do in order to make your comfort, I will start doing that. I will keep my foot from here. I will sit like this way. I will sit like this way. Okay. I will keep my feet on this front seat. Okay. And when if the passenger come, then what will you do? If the passenger come, then of this seat, then what you will do? I have to use my own. I have to keep my feet like this way. Okay. I will sit properly that this time, and I will sit. I will keep my feet like this way. Okay. Understood? I will not keep the feet here because this person has arrived now, whose seat was reserved here. Similarly, carbon also show this type of behavior. Okay. If we have carbon and carbon has utilized its full combining capacity. How many means, for example, if I'm having carbon, okay, and this is the carbon, 4 carbon atoms, 4 electrons of carbon atoms, and this is also 4 electrons of carbon atoms. Okay. This is bonded with hydrogen. This is also bonded with hydrogen. This is bonded with hydrogen. This is also bonded with hydrogens. Okay, so this is hydrogen atoms. This is hydrogen atoms. But here you see that, and this is what is this? And this is also bonded with this carbon atoms. But these electrons are free. So we'll say here that there is a bond, there is a bond, there is a bond, there is a bond. So this is like this, and this is like this. Okay. So every carbon atom has been bonded with 3 electrons. Okay, 3 bonds are there. Only and single electrons is there for every carbon, but it is not bonded. So what it will do? In order to attain stability, these 2 carbon atoms will combine together and they will make a bond like this. There is double bond between them. These 2 carbon atoms will join together and will bond. But what if this double bond is, if we treat this one with hydrogen gas in the presence of nickel, palladium, and platinum, then what would happen? This hydrogen has to react with this one. So this bond will be broken, and again, these 2 hydrogen atoms will be attached with this one. So here, this is considered to be as unsaturated hydrocarbon. Why? Because this carbon has not utilized its full combining capacity. Still, it is making 4 bonds. 1, 2, 3, 4. Every carbon atom is making 4 bonds. 1, 2, 3, 4. This one also 1, 2, 3, 4. They are making 4 bonds. They are stable. But if we react it, if the hydrogen gas comes, then again, I'm stable. I'm just, if there is no passenger, then I will keep my feet on the front seat in order to feel in order to have more stability. But if the passenger came, then what would happen? If there is a bus, if you are moving in a bus, if there is no passenger near your seats or the beside your seats, okay, then you will keep your bag stuff on that seat. You will relax and you will start using your mobile phone and other whatever stuff you are using. Okay. But if the passenger come, then you have to remove that bag and you have to keep it somewhere so that that passenger can sit. So if I'm saying that if the bus is not saturated when you are having your bag on these beside seats, because it is not saturated. But when the bus is having every passenger is there, if the number of seats and the number of passengers are same equal, then no other passenger can be added to the bus. In India we can add, but in foreigner we cannot add more passengers. Okay, why we cannot add this one? Because this is reserved and you cannot take the passengers without these having seats. Okay, so it will be reserved if it means the full capacity of the bus has been utilized when every passenger is taking his seats. Okay, the same is for this carbon also. When a carbon is making 4 bonds, every carbon atom is making 4 single bonds, then it is saturated hydrocarbon. And if it is not, if it is making double bond in order to attain stability, if it is making triple bond in order to, here it is making 4 bonds, but not the 4 single bonds. Yeah, this is Single bond is a single bond, but these two are the double and triple bond. So if every carbon atom is bonded with 4 other carbon atoms, it's single bond, it is saturated hydrocarbons. Why saturated? Because if now this every carbon has utilized its full combining capacity. So if you react it with chlorine, so now you cannot add the chlorine to this like this. You cannot add. Like we will have five, one chlorine atom can be bonded like this. No, you cannot add. You cannot add chlorine like this. No, you cannot make 5 bond. You have to remove one hydrogen in order to make this bond. You have to remove it. So when a carbon, when we have a carbon atoms in which each carbon atom has not utilized its full combining capacity, we called it saturated hydrocarbons. Sorry, unsaturated hydrocarbon. And if it has utilized its full combining capacity, we called it saturated. Okay, so saturated means full combining capacity is being used of carbon, and unsaturated means, tell me, not full combining capacity means there is double and triple bond between two carbon atoms. Okay, any two carbon atoms. Understood? Understood. So let you write it first. What is saturated and unsaturated hydrocarbons? Write down the definition of saturated and unsaturated hydrocarbons. Saturated hydrocarbon the compounds in which each carbon has utilized is its full combining capacity. Okay, i.e. there is single bond between every carbon atom. Every carbon atom. Okay, mark my point. I'm just talking about carbon atom, not carbon oxygen. Okay, carbon atoms. Okay, and alkanes comes under this category. Alkanes comes under this category. Under this category, we will learn that what are alkanes. Okay, noted this one. Noted. Now moving to the next part is unsaturated hydrocarbon. The compounds of hydrocarbon, the compounds of hydrocarbon in which there is double or triple bond between any two carbon atoms, i.e. each carbon has not, i.e. each carbon has not utilized its full combining capacity. Okay. Understood? Which comes alkene, alkene, E-N-E, double bond, and alkyl, Y-N-E, triple bond, comes under this category. Maybe confusing double line and triple line. Comes under this category. Under this category. Done? Noted, everybody?
Yes, sir.
Okay, so take care, dear
Yes, sir.
students. That's all for today. We'll meet you in the next class. I hope you enjoyed the class. You understood each and everything. We'll meet you in the next class. Thank you for joining this class. You can leave.
Thank you, sir. Bye, sir.
Thank you,
Okay,
sir.
you too, beta.